Right, so this is going to be a quick slide here, and on here I'm just going to talk more formally about the steps for conducting a hypothesis test using this analysis of variance test. And then we'll go over to examples using more concrete numbers on the .cam as usual. So your first steps for conducting an analysis of variance are to write the null and alternative hypotheses. And with this test, it's nice because they're always the same. And you can write out specifically which populations you're thinking about, or you can even write it out just like this, the same every time. Where your null hypothesis is that all your populations have the same mean on whatever variable it is you're measuring, and your alternative hypothesis is that all populations do not have the same mean. So if you reject the null hypothesis, you'll have evidence that at least one of the populations you're interested in has a different mean than, some of the other populations you're looking at. The next step is to calculate the F statistic using mean square between and mean square within. So we just looked at that on the .cam, where you calculate the F statistic by dividing mean square between by mean square within, and that'll give you some number that can then be plotted on that F distribution. But the F statistic is your test statistic for this test, just like the T statistic was your test statistic for the 1 sample and 2 sample t-test that we did in the last couple of weeks. The next step is to decide whether to reject the null hypothesis. This is exactly the same as it's been the last couple of weeks, which I think is nice, kind of getting at a new material and into variations on old material. But if your p-value is less than your alpha level, you would reject the null hypothesis. And if you reject the null hypothesis, you'd be able to make this statement. If the population means were all the same, there would be, some percent chance, based on your p-value, that we would get an F statistic as large or larger than the one we got. So a very low number there, is evidence that the population means aren't the same. So in other words, if you get a really unlikely F statistic based on a world in which all your population means are the same, you would reject the null hypothesis that all the population means are the same. All right, so we're going to head back over to the document camera now and go through some examples of an analysis of variance test.